Hi, I'm Pete Bergstrom with Horizon Hobby, and I'm a product developer and the category manager for engines. Today we're going to talk about the new 62cc engine from Evolution with the EFI system on it, which stands for electronic fuel injection. This is our new 62cc engine. We've been designing and working on this for about 4 years. It's a clean sheet design from the ground up that we decided that we wanted to get into this marketplace to support both the sport, aerobatic, and the scale guys. When we first laid out the parameters for the engine, we knew what size we wanted it to be, but we also knew that it had to fit into existing airplanes. So we made the mounts fit the DA60, we made the propeller drive fit the DA60, and we actually made the exhaust to fit the DA60. So if you've got those accessories or an airplane that's fit for that kind of an engine, then this will drop right into place. Kind of like if I wanted to make a new standard servo and I didn't make it the right size. So that was the idea behind it. The engine comes with the muffler that you see here, and it comes with our new fuel injected carburetor system, which I'll get into in a little bit. On the back side, we've got the ignition system that you see here, and then as I rotate it around, you'll see the carburetor, and this black box on the side of the carburetor is the electronic controls for the fuel injected system. The cool thing about the engine is that it runs off of a single 2S LiPo battery, and it drives both the ignition system as well as the fuel injection system. Okay, what I'm going to do now is I'm going to talk a little bit more specifically about the fuel injection system and what it is that goes into it and how it is to operate. Okay, what this version shows you is you can see a little bit more of what we've done here. The fuel injection system essentially looks like it's the same size as the Walbro carburetor, but it is not. The design prospects that we had to do were to come up with a smaller injector, come up with a system that would fit within inside of our airplanes, and all do it at a price point that everybody could benefit from. So we'll take a look at what I've got here. This tube here is your fuel inlet tube. It's capped off right now. On the side here, if you look down real close, this tube here is the fuel return line. So any extra fuel that's not being used gets returned to your tank. And then your tank still requires a third line to vent for pressure. So it's a 3-line tank that's required on the system. The system has a similar pump to a Walbro carburetor, so it's a diaphragm style pump. In the middle here, we've got another tube coming out. We use a primer bulb, which can be remotely mounted any place within the airplane with just a tube going to it, and you need that just for the first flight of the day. And I'll talk a little bit more about the actual operation later on. Some people have been asking me all day long, why did we try to go with EFI? There's a lot of obvious reasons, but the very first and basic reason that we wanted to do this is that we wanted something that was easy for all of our customers to use. In today's marketplace, with so many modelers that start with just electric airplanes, and a lot of times their clubs are electric only airplanes, there's nobody around that's got any experience with gasoline. But what about the guy that wants to build into a bigger airplane? Or all of a sudden he wants to use an engine, fuel-powered engine that actually has some sound and noise to it, like a real airplane does. But he has nobody that can help him. So we sat down, and 4 years ago we decided that we needed to solve this problem, this operation problem for the new guy in the gasoline engine. So we started with this size engine here, and we needed to get away from, how do you tune the needles? There are no needles that you tune on this. How do you choke it? There is no choke. It's all built into the electronics. The system is completely integrated together with our ignition system, which you see here. We've got some wires that are attached to the engine. This first wire right here is a ground wire. On the other side of the engine, this yellow wire is a temperature sensor for the case, so it understands what the temperature sensor is. This green wire coming across actually plugs into a third line on our ignition system, and that allows us to use the same magnet sensor on the front of the engine that you would use for your ignition system to also, essentially it's a crank sensor for our electronic fuel injection. It tells it when to fire, it tells it what kind of RPM that we're looking at. The other sensors that aren't quite so obvious is there's a very small hole adjacent to the Venturi here. That's an intake air temperature sensor, and so it sucks air through the system there and it gets the intake air all the way through it. And then inside of the black cover here and in the electronics, we have a throttle position sensor, which is a simple rheostat. But that allows the system to know what kind of power the customer or the user is actually asking for. When you mount this into your airplane, the attachment for the throttle is a very simple lever, just like you're used to. And you can see it right here, and it goes in about a 90-degree arc. And so it's simply a matter of attaching it to your throttle servo with no other odd geometry going on, but just a nice solid link to the throttle servo. And in your transmitter, you just want to set it up so it's even throw as close to 100% as you can. In the instruction manual, we go through that. Now, when you first go to operate this engine, first flight of the day, you'll take that remote primer bulb that I talked about, and you pump it 6 or 8 times. What that does is it provides pressure into the throttle body so that when you go to start it the very first time, fuel will actually go through the injector. The injector itself is actually very small. It's one of the problems that we had to solve here, and it's underneath this small cover here. So if anybody's had a chance to see an actual injector like an automotive injector, they're quite large. We had to come up with a much, much smaller injector. And we went to this company in St. Louis here in the US who's already solved these small throttle body problems before, and we've been working with them for the past 3 years to get this unit to work perfectly. Now, the standard operation, when you go to start the engine, pump up the fuel bulb like I was talking about, turn the system on, and in about 4 to 6 flips, the engine's going to start. There is no choking process, like I said before, but there is an electronic choke going on where the system is feeding a little bit of extra fuel for the first 20 to 30 seconds while the engine warms up. After that, every time you move your throttle stick all the way to 100% or above 95%, the system starts to hunt, and it hunts for the best RPM, whether it needs to lean the system or to richen the system. That way you can put whatever propeller on there that you want, you can use whatever muffler system that you want, and it will find its own best way all the way through. This makes it much, much easier. You don't have to understand the why it's doing it, but the system understands it all by itself. So the goals for the project were to make it easy to use, easy to start for the new guy, provide great power. It provides the same power as it would with a carburetor, and then at the end of the day you just charge your battery and you come back out and do it again the next day. Very little maintenance to the system whatsoever, fairly simple to set up, slightly different three-line tank system versus the 2-line system that you might be used to. And that's it. We think we've met this goal. The thing about this kind of a project is if you come up with this new technology and it works really cool, but if you price it so that it gets so expensive that nobody can take advantage of it, then that doesn't work either. So what we did is we worked really, really hard to simplify what's going on in here, which can bring the cost down so we can provide this engine complete with the muffler and the fuel injection system to the market for $579. We think that we hit all the goals of the project.